Hi, and welcome to day 3 of the Advent of Code 2021. This is Dad and Kids Coding. I'm Dave.
I'm Thomas.
And so today's problem is fairly simple. We're given a sequence of numbers and represented in binary, and we basically need to find which is more common, a 0 or a 1 in each position. And that produces something called the gamma rate. So the first position has more 1s than 0s, so the first bit of the gamma would be a 1. The second bit would be a 0, and so on. And then we also calculate the epsilon rate, which is, in this case, is 31. In other words, all 1s in those positions, minus the gamma rate. Or we could just count it as the number of the less common. Either way works. And then we multiply the two together to get the final result. So let's go to the problem. And I just was testing around. Okay, so here's our, we've copied over that data, and we're ready to run day 3A on this. So let's run the test and see what happens. And not surprisingly, as we did previous days, we don't have a day 3A. So we're going to create this, and we'll put it in byte string is fine. And we'll leave it unclassified for the moment. And then now we need to actually implement this. So, we're going to need an array of positions for each number. So first of all, we'll calculate. Let's just say lines is going to be equal to self lines. So we'll save that, and let's step over that, and we see that lines is, inspect that. Lines is this array that has a sequence of numbers in it, or a sequence of strings in it. So we can leave them as strings and process them that way, but we need a couple of other pieces of information. So we need the counts of the number of 1s. So we'll count the number of 1s. So counts is going to be equal to well, what we're going to do is we don't know how long the strings are, because although this example has them 5 characters long, the full data has them longer. I don't remember what the length is, 8 characters or something. So I'm just going to start this off as nil because we don't know how big to make it. But then we're going to then loop through all the lines. So lines do, and we're going to say for a given line, so what do we want to do with the line? We want to say, so a line is going to be one of these strings, like 1 0 1 0 1. So we want to loop through that, and we want to but before we do that, we want to get an array. We want to set counts up properly. So let's say counts. So counts if nil, in other words, we haven't initialized it, then we will initialize it. So we'll set counts to an array new, and how big to make it? Well, we'll make it the size of a line, so line size, and let's enlarge this into a bit, line size, and with all zeros. So we'll initialize it with zeros. Okay, so let's just try this. Save this and get counts. Okay, so so now we want to loop through the line, through all the characters, and so we're going to say loop through the line, and we're going to do with index do. So what with index do does is that it loops through all the elements of the line, but it passes to this block two things. One is the character, and the other is the index. So this is going to be the position of the particular character within the string, and we're going to use that to fill in the counts array. So then we'll just say if the character is equal to a 1, if that's true, then we will add 1 to that position of counts. So counts at index put counts at index plus 1. So we'll just add to that position in the counts, and that's the end of our loop. Okay, so basically we're going to loop through all the characters in the line. If the current character is a 1, then we'll increment the value at that count. Otherwise we'll do nothing. And we'll do this through the line, and then we'll do this through all the lines. So now we have all of our counts. So now we need to create the gamma value. So let's say gamma is going to be equal to 0. Let's just save that so that it, and then we can we need the number of lines. Let's call it n lines, or no, let's call it the half point. Because if we've got at least that many 1s, then we want a 1 in the gamma value. If we have less than that number, then we want to put a 0 in the gamma value. So half point is equal to lines size divided by 2, and so we're actually going to, we want the integer divide. Smalltalk has a very full number stack, and so if line size was an odd number, if I divide it by 2, I get a fractional result, which is not what I want. I want the integer value. So the double slash is divide with truncation, which is what I want. Right, so now we want to say, go through our counts, and counts do, and now we've got an individual count, and we want to say if count is greater than half point. If that's true, then we want to there's a couple ways to do this. I'm just trying to figure out what the most understandable one is. While I'm thinking about it, let's just reformat this a little bit. If it's true, wait, that's fine. If it's true, then we want to say that gamma, no, I know what I wanted to do. I had a better way of doing it, so we'll do it the better way. So, if count is greater than half point, there's a method called asBit that will, if that's, so this returns a Boolean value, either true or false, and there's a method called asBit which turns true to 1 and false to 0. So we're then going to say that gamma is going to be equal to, or it's assigned, so I want to double gamma plus this count converted to a bit. And so now gamma will be the correct number, I believe. And we need to calculate epsilon. So we could do epsilon a couple of different ways. Let's just set epsilon and for now we'll just do epsilon is epsilon plus epsilon plus 1. Okay, so this is going to fill in all the bits for epsilon, and then when we're done the loop, we'll just say so epsilon is now going to be epsilon minus gamma, and then finally we return gamma times epsilon. Okay, so it's a kind of a long method, but hopefully it's correct. Let's just see. So temporary variable, yes. Temporary variable, yes. Okay, so now let's just say continue and see what happens. So proceed. And it passed. We got 198 as we'd hoped. Okay, so and then when we use the data for day 3, we got this big number instead. So let's just actually, if we just go to here, actual inspect. Okay, so I don't remember how I got this the other time. Let's try this. Copy and paste in here and submit.
Hey,
and we got the right answer. Okay, I was a little bit worried about what it would do if there was an even number of values, but it doesn't appear to be a problem. So let's just go back and fill in this value in our test. So that's blue. There we go. So let's go and see what part 2 looks like. So part 2, next you need to verify life support rating. Okay. Oxygen and CO2 rate scrubbers. Okay, before searching for either, both values are located using a similar process that involves filtering out values until only one remains. Before, start with your full list of binary numbers from your diagnostic and consider just the first bit of these numbers. Then keep only numbers selected by the bit criteria for the type of rating value for which you're searching. Okay, you only have one number left. Stop. This is the rating value for which you're searching. Otherwise, repeat the process considering the next bit to the right. Okay. The bit to find the oxygen, determine the most common value, 0 or 1, in the current bit position and keep only numbers with that bit in that position. 0 and 1 are equally common. Keep values with a 1 in the position being considered. Okay, to find CO2 scrubber, take the least common value. For example, start with all 12 numbers and consider only the first bit of each number. There are more 1 bits, yes, than 0 bits, so we keep only the 7 numbers with a 1 in the first position. Okay, Okay, then consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bit, so keep only the 4 numbers of those with a 0 in the second position. Okay, so we're not going to the second bit of all the numbers, it's just the remaining ones. Okay, so we keep only the 4 that have those. In the third position, 3 of the numbers have a 1, so keep those 3. Fourth position, 2 of the numbers have a 1, so keep those 2. Fifth position, they're equal numbers, 0s and 1s. So to find the oxygen generator reading, keep the number with a 1 in that position. As there's only one number left, stop. The oxygen generator rating is that number, which was one of the original numbers. Okay. To determine CO2 scrubber, start with consider only the first bit of even fewer. So keep only the 5 numbers with a 0 in the first position. Then consider take the fewer. Okay. And then we multiply those two values together. Okay. So we do something kind of similar, but similar but not identical. Okay. So let's see if we can figure this out. Copy. Okay, so now we want day 3B, day 3B, and say it's nil again. Okay, so let's run the test and create day 3B. Put it in byte string. Okay, so So let's take self and split it into lines first of all. And we may have So I'll save that as we did before because we're going to want it twice, I think. Okay, so now we have the lines. Now we want to filter those lines based on either the most or the least common. So let's say oxygen is going to be lines day 03 filter so we want to filter starting in position 1, first position, and we want the most common values, right? Most common. Okay, so let's pass in most. Okay, and then let's say CO2 is filter again for the least common. Because they're almost identical, except that one we're looking for the least common, so it's just the way we're going to do that comparison at the end. Okay, so, and then we're going to return the oxygen times the CO2. Is that right?
I think so.
So the reason I wrote calling a filter method is because yes, multiply the two values to get the value of 230. 230 is the value we want. Didn't plug that in properly before, so we'll go back and plug that in. So that looks right. So let's save that. Save it. And yes, it's a new variable. Yes, it's a new variable. Yes, it's a new variable. And let's just go back to day 3 because we're checking to see the wrong value. We want to look for this value instead. Okay, save that. And I'll just tell it to proceed, see where we get. Okay, so array did not understand day 3 filter 4. Not surprising. So let's create that and we'll put it in array. So we have self is an array of strings, and we're going to loop through this, filtering out the values until they match. So I think we first of all have to find out what is the, okay, start with all, consider the first bit of each number. There are more bits, so we need to find out whether it's more or more 1 bits than 0 bits, or vice versa. So okay, so we're first going to have to loop through and find out whether it's 1 or 0. Okay, so now this is very similar to what we did on the other one. So perhaps we should be finding out, perhaps we should refactor this to use the same code. So let's just close this and go back to our day 3a method. Okay, so here's our day 3A method. And so there's a couple of things we could do here. We could restructure this. Huh. I don't think that's going to work. I thought it might, but because what we want to do is we want some of this code and some of this code, but we don't want all this code. So we are going to have to do something like this. So let's just copy this code. Okay, copy that. And now let's look at the day 3B code. And here we want this day 3 filter for. Okay, so I haven't actually written any code yet for this, so let's just do that. So paste this. So lines, we want self. So counts as nil. Self do. Okay, save. Okay. So we want to loop through all of our lines, but we don't want to count up all the counts. We want to just count in this position. So we don't need the nils. We need so all we really want to know is how many of right, okay. So we want to we don't want counts, we want count. And count will start off at 0 because we're only going to look in one particular position. So we're not going to loop inside here. We're going to, and we don't need to do the array either. We're just going to say if so instead of character here, we want line at, let's call this position. And here we'll put in position. So we're going to loop through all the lines in self. And if we see if the character out of that position is a 1, then we're going to add to the count. Count is going to be assigned count plus 1. Okay. So if we see a 1, then we'll add 1 to our count, and that's the end of the loop. Okay. Now, so we've got the count. So if the count is greater than So if self size divided by 2 is less than count. So there's two possibilities. Could be true, it could be false. Okay, so let's handle the true case first of all. Why is this so? Minor reformatting. Okay, so if it's true, okay, so I'm having a little difficulty keeping this all straight in my head. So let's for now just put it in a self halt. So what this basically says is if we get to this point in the code, stop, and so we can try and figure out what's going on. So halt. And one thing I wanted to do first is, so if the size of this array is 1, then we've already found the answer. So self size equals, may as well say less than or equal 1. No, if it equals 1, so it's less than 1. If true, then we want to say return self first, because we found the correct answer. But we're supposed to turn it into a number, to a binary number. So self first, so we want a number. No, I'm trying to remember what the method is called. There's a method in integer, so let's just go and look at integer. That's what I wanted to do. Yeah, there we go. So integer on the class side has a method called oh, maybe it's in number. Read from base. There we go. And is it an integer as well? Yes, read from base. So this will convert a string into a number using a particular base. So we want to read from with base and read from self first, and the base is 2, because we have to convert this as a binary number. Okay, so I actually want to implement a test for this. I don't want to just do this from the code that we have, because it's a little too complicated. So I'm going to save this. Okay, that's giving me a bunch of warnings, but we won't worry about those. So I'm going to put go over to the test and I'm going to add an extra test. So add a new test. Test filter. Oops. No, I don't want all that. I want that. So I'm going to say self assert that I'm going to try an array that has just the number 10101, which should be 21. What was it called? Day 03 filter 4. There we go. Filter position 1 for most, and I'm going to assert that that is equals what is it? 21. So I'm just running a simple test to test that this method that I wrote actually does the right thing. So let's test that first. And it did. Okay, so if there's only a single value, then it returns the correct answer. Okay, so now let's try another case. So self assert. So this is test-driven development, and it's basically saying I want to so 10101 and let's try 11111. Day 03 filter 4, starting position 1, filter for most, equals. Okay, so I think this should return 31, because that's what this number is, and this one should be, it should be filtering for, actually let's try a different example first. So let's try 00000, and this should return 21 again. 21. So it should find that of these, the most common is it's supposed to default to the 1 case, I think, if I remember correctly from. So with oxygen, equal number of zeros and ones. So for finding the oxygen rating, which is the most, keep the number with a 1 in that position. Okay, so that should return 21. But this one should be 31, because this one, the first number will be the same, so it'll keep both of those for the first round, and then the second round it should keep the one with the 1, which is this one, so it should give 31. Let's zero in this last position just for fun. Okay, 30, save. Okay, save. Here we go. And let's run this test. Okay, so not surprisingly we came to the halt because we didn't break out of that first case. So what do we have at this point? So we have count is 1, and self is the array that has these two values. So we counted 1 in the first position. Yep, that's correct. And so we're in this case where the size of this right. This is tricky. So string is most, so we want most, looking for the most common cases, and so we want to why am I doing this test for the size less than the count? Oh, because we're trying to find out what the most is. So if the size is less than count, then it means 1 was the most common. And so if it's most, so I'm going to do 2 different cases here. So I'm going to say let's say, call this matching. So if match is equal to most, then so if true, if false, let me just go back here. So there are more 1 bits. So I'm looking at this code here. So start with all 12 numbers, consider only the first bit of each number. More 1 bits than 0, so we keep only the 7 numbers with a 1. So we want to find, so count is the number of 1 bits. So if it's more than size divided by 2, that means there's more 1 bits. If it's equal, we do something special, and okay. So this code here that I'm looking at should be deciding what I'm going to search for. So I'm going to say search, and I'm going to set search so search is going to be by default a 0. Okay, so I'm getting a little bit bogged down here. So under some circumstances I want to set search to 1. So we'll figure out what that is in a moment. And then when I'm done that, I want to call self, no, not self. So I want to take that, I want to take self, I want to filter it. So I want to say self select, and I'm going to select all the elements that have a search value in the correct position. So I'm going to have a search for an element, each is what we typically call it, so I'm just going to call it each. So I want to find an element whose position where each at position is equal to the search value. Okay, so I'm going to select those, and then I'm going to call those and ask those to day 03 filter for position +1, searching for the same match. Okay, and that's what I'm going to return. Okay, complicated. Okay, so I'm gonna, so let's save this and let's step over it a bit and see what happens. Okay, so count is now 1. So we found one that has a, at position, and position is 1 also. So I found one element from these two values that has a 1 in position 1. So then I set search to 0, and then I'm going to self-select. So let's go over. So let's just see what this returns. So inspect that. Whoops. Inspect that, and it returned the one that had a 0 at that position. Okay, which is good. That's what I wanted. Now let's just go back and change this to a 1, and again loop over, and now try again. And we find the one that has a 1 in that position. Okay, so it's doing the right testing there, and then we're going to filter for position +1, and sooner or later we're going to get down to a case where there's only one value, and we'll return that one because of this line up here. Okay, so the only tricky part left is to figure out when to set the search to 0, because I've set it to 1. Okay, and this is the messy bit. So if I'm searching for oxygen, where I want the one that has the most bits, then let's go back here. So if this is true, then there are more 1s than 0s. And if I'm looking for the most, then that means that I want to I'm missing a detail here that I need to look. If there are an equal number of 0s and 1s, and we're looking for most, then we keep the number with a 1 in that position. Okay, so I guess we have to handle that case separately. So if false, I'm not sure what these are at the moment, so let's just go back here. So if false, then if self size divided by 2 is equal to count, if true, not need all these cases, but I'm going to put them in first and then we'll worry about whether I need them all. Okay. So, if the count is bigger, then it means we've got more ones than zeros. So, if we're looking for most, then we're done because we're going to search for ones, which is good. But if we're searching for, what is it, least? So match equals less, was it? If true, then set search to 0. Otherwise, if they're equal, then if match is less, if true, this looks very similar to the other code. So we'll clean it up after. Let's get it working first, and then we'll worry about cleaning it up. Otherwise, so there are more ones. This is the same number of ones and zeros. This is more zeros. So if there's more zeros and we're looking for most, so match is equal to most if true. So there are more zeros, we're looking for most, so we want to set search to 0. Okay, maybe. So I probably should have written tests first, so let's just save this. And that's not helpful. Let's go back over here. So test D3, no, that's not where the code is. Let's look for senders of this. So we are one of the senders. This is the one that I'm looking for though. Most and least, right? Okay. So let's look for definitions of this. Oh, it didn't save it. Oh, so unhappy. Okay. That's frustrating, but here's what it is. Okay, I'm just going to put this into the admin of code. Okay, now let's get this. Very frustrating.
Well, you said you were going to redo it.
Yep. Okay. So, but I wasn't quite ready to redo it just yet. So if this is, it turns out that I had both cases for less and equal were the same here. So I'm just going to try this, and I may or may not get it right, but let's, then we want to set, so if match is least, if true, set search $0. Otherwise, if match is most, then I want to set search Okay. So the logic here is, okay, the logic here is that if this is the case, then there are at least as many zeros as ones. Sorry, at least as many ones as zeros. And if I'm looking for the least, then I want to filter and keep the ones that have wrong. So this is sorry. If this is true, then this is there are more ones than zeros. Okay, so if there's more ones than zeros or an equal number, then if it's least, then I want to search for zeros. Otherwise, I want to search for ones. If it's not, then it means that there are more zeros than ones, in which case, if I'm searching for most, then I want to search for zeros. Otherwise, I want to search for ones. Okay, so I think that that's right now. Okay, so let's run our test. Okay, so our test passed all these cases. But those were, let's try a couple more. Okay, so let's try simple values, like just 1, 0, and 1, 1. Searching for most should equal 3. And then if I'm looking for least, then this should equal 2, I'm thinking. It's an equal number, and now let's try with 3 values, 1, 0, 0, 0, 1, and 1, 1. So
Is
this
that dot properly placed there?
yeah. Oh, it doesn't matter. Yeah, there can be a space there or not. It doesn't matter.
Okay.
So if we're looking for most, we should find ones. That's what we should filter for first. Then we should filter for zeros, because there's more zeros than ones in the second position. And then we should find an equal number of zeros and ones, in which case we should search for the one, so this should equal 5. Okay, so let's see. And a loop. And self is an empty array. Okay, so we got to an empty array quickly, and that did not do the right thing. So let's self halt. Actually, I don't have to do this. Just put a halt over here. Should have. No, I didn't. Maybe it did. Save. Yes, okay. So run our test, and we get to a break. Okay, so let's step over. Let's go into this. Okay, so we're going to go over. Okay, so position is 1. Count is 2. Searching for match. Match is most. So if this is less than or equal to count, then if it's least, then we'll do search is 0. It's not. So we come through and we inspect that. It's a list with 2 things, so that's fine. So step over that and over that, and then go into that. So good measure over. Size is equal to 2. Search is equal to 2. Okay, so count is 1. Is this less than or equal to count? Yes, it is. So match is not least, it's most. So we're going to search for 1s. And again, we're going to find the right value. So I'm going to step through this. And we return that, and it equals 3. So that's good. Now, this one is the one I think is going to loop. So go into this, step over. Okay, so the problem here is that we're going to so match is least in this case, so we're going to search for 0s, and we're in position 1, so we're not going to find any 0s. So this is going to return an empty array, and then we tell the empty array to do a date filter, which is going to work with an empty array, and it's going to go into an infinite loop here. So we need to save this first. So let's say matches or filtered. Let's call this is the filtered. Is equal to this. And then if filtered size is equal to 0, that means we didn't find a match, so we'll if true, so we'll just set filtered to self, because we don't want to search an empty one, and now we can just say return filtered. Okay, so save that, new variable, and step through this. Where is my mouse? There's my mouse. So step over. So search is going to be 0. Filtered is going to be empty. So size is going to be equal to 0. So we'll set filtered to self, and then we'll search from the next position. And it worked. So let's proceed. And our tests work. Okay, so those tests work. Let's try day 3 now. So it worked. We got our 230. So that part worked. And now we've got a big number.
We've seen bigger. Yeah, we've seen bigger.
And so copy that over to this day 3 and replace this. Save that and go over and see whether it's right. Let's see. And we got the right answer.
Yay!
So that took us a while.
Small bit.
But so we now have a few different methods that we should track down. So let's go and look at day 3B. Sorry?
Make it green.
Yes, make it green.
Hey,
Thank you.
There we go. It's a reward unto itself.
Day 3B, so let's find the definition of that and browse that, because, could have fixed it where I was. Okay, so it says yet unclassified. I want to put an extension, advent of code, done. Okay, and this calls day 3 filter for. And day 3 filter for is already an advent of code. Do I call any more methods here? Nope, I just call this recursively, so I think we're good. No, so it's telling me rather than checking size equals 0, I should say is empty. Okay, so let's do that. Okay, made that warning go away. And I've got this, all looks good. So let's just run all of our tests one more time. And, I still have a break in my test, but that's okay, I can proceed. It passed, but let's go and take that break out. Okay, and now let's run our tests again, and they're all passed. Excellent. So that was a bit tedious perhaps, but I hope you learned something from it, and we mostly had fun. We hope you did too. So we'll see you tomorrow for day 4. Bye now.
Bye.